Good morning, students. So, in previous class we have studied about metals and non-metals, about its physical properties of metals we have discussed. We have started chapter metals and non-metals, in which we have seen the rough definition of metals and non-metals, and we have discussed physical properties of metals. In today's lecture we will discuss about physical properties of non-metals. So please open your book so that we can start. Okay, so I hope that everyone just opened the book, and let's start this chapter. The topic: physical properties of non-metals. So let's see some of the general properties of non-metals. The first properties is we are about to study, that is malleability. Malleability means what? You know, malleability means that it is a property of metals, means it is a property of metals specially, that metals can be beaten into thin sheets. So the ability to make thin sheets of a particular substance we call malleability. So non-metals are those substances which are not malleable. That means they are brittle. Brittle means what? That they can easily break. As you can see in the figure, if you beat phosphorus, it will just become a powdery substance. So they are brittle. For example, you can see sulfur and phosphorus. Now let's see the another physical property, that is ductility. Ductility means what? It is a property to draw into wires, right? So generally this property belongs to metal only, but ductility, non-metals are not ductile. Why? Because you cannot draw non-metals uh, to thin wires, right? You cannot draw non-metals to into wires. So it is ductility. Non-metals are not ductile. For example, you can see silicon and boron. These are non-metals which you cannot draw into thin wires. Now let's move. Sonorous. Sonorous means what? Ability to produce a ringing sound. So non-metals are not sonorous, means they cannot produce a ringing sound. It cannot produce when hit with a hammer. For example, bromine, fluorine, etc. So this is all about the third property, that is sonorous. Let's move. Density. Generally non-metals having low density. Okay. So for example, hydrogen, carbon, etc. In the previous classes we have discussed density in a broad manner. Like you can see in your book that non-metals usually have low density and are soft. For example, exception is there, that is diamond. Diamond is the hardest natural substance known. So question may come that which is the hardest substance, which is the natural occurring hardest substance which is known to us. So your answer will be diamond. So it is an exception. Non-metal, which non-metal is hardest natural substances? So your answer will be diamond. But generally non-metals are low density and are soft. Okay. Now melting and boiling point. So non-metals have low melting and boiling point. Okay, it has low melting and boiling point, but there are some exception, like graphite. It is a form of carbon having low melting and boiling point. Let's move. Hardness and softness. So non-metals are generally soft. As see, the properties have the metal having properties just opposite non-metals will have. Like metals are hard in nature, hard substances, non-metals generally soft. So just opposite to metals, non-metals showing those properties. So non-metals are generally soft. For example, carbon, phosphorus, etc. So carbon having three forms. Carbon generally exists in three forms, like one carbon, second graphite, and third diamond. Generally non-metals are soft, but the third form of carbon, that is diamond, it is hardest substance known. Now conductor of heat and electricity. So we know that metals are good conductor of heat and electricity. So now we're talking about non-metals. So just opposite to that, that is non-metals are generally bad conductors of heat and electricity. So one question may come like, why copper and aluminium are used for making electrical appliances or cooking utensils? So your answer will be that copper is a metal, so it is a good conductor of heat and electricity. So that is why we used copper and aluminium for making cooking utensil or electrical wires. Okay, so I hope it is clear to all of you. Non-metals are generally bad conductors of heat and electricity. For example, iodine, neon, etc. While metals are good conductors of heat and electricity. Now let's see. There are some exceptional cases. Okay, so few more physical properties I want to discuss. That is in your book you can see about color. Color. What is the non-metals color? Non-metals come in many colors. Okay. For example, you can see in your book that sulfur generally found in yellow color. Phosphorus, white or red. Then chlorine, greenish yellow. Bromine, reddish brown. So these occurs in many colors. Non-metals generally occurs in many colors. What about its appearances? So non-metals have a dull appearance. You know that metals are generally shiny appearance. So just opposite to that, non-metals having a dull appearance. That is, they don't shine. Okay, like for example, you can see there are many, generally non-metals are having dull appearance, but there is some exception like graphite, iodine. These are non-metals. They have to show a dull appearance, but these are the exception. These are the only non-metals those have which having a lustre, means which have a metallic lustre, like graphite and iodine generally having a good appearance, a shiny appearance. So here we have finished. One more physical property left, that is tensile strength. So tensile strength, I told you that ability to bear stress. So non-metals have low tensile strength. Okay, like metals having high tensile strength, they can bear a lot of stress. Here non-metals having low tensile strength, that is, it can be easily broken. So I hope that these physical properties of non-metals is clear to all of you. Now let's see the exceptional case, though we have discussed already about the exceptions also, but let's see the exceptions once more. Electrical conductivity. Carbon. Carbon is a non-metal. So having a non-metal, it means what? What is the electrical conductivity of a non-metal? It is a bad or poor conductor of electricity. So carbon is a bad conductor of electricity. But if we talk about the forms of carbon, so one form of carbon, that is graphite, it is a non-metal also, but it is a good conductor of electricity. So a non-metal which is a good conductor of electricity, your answer will be graphite. Graphite is a non-metal which conducts electricity just like metals. Now one more exception you see, lustre. Lustre means shiny appearance. So generally non-metals are non-lustrous. That means it is a dull appearance. But one non-metal named iodine, it is lustrous, having a shining appearance just like metals. Okay, so iodine is a non-metal which is lustrous, having a shining surface. Now you see hardness and softness. So alkali metals like the group 1 metals, no, sodium, potassium, these we call alkali metals. These are generally soft, just like non-metals. So Carbon in the form of diamond is a non-metal which is extremely hard, just like metals. See, the two exceptions are given. Generally metals are hard, but the two metals which are soft is sodium and potassium. One more metal you add, lithium. And generally non-metals are soft, but exception is there, diamond. Diamond is a non-metal which is extremely hard. One more you see, physical state. Mercury is a metal, okay, but it is liquid at room temperature. We have studied this one also in a physical properties of metal. So it is a metal. Mercury is only metal. Please point that mercury is only metal which is present liquid at room temperature. Generally metals are what? Solid or liquid. Generally metals are solid. But one exception is there, that is mercury. It is the only metal which is present in liquid form at room temperature. Now you see melting and boiling point. So sodium, potassium, cesium, gallium metals have low melting points. Okay. Generally sodium, potassium are metals. So metals having high melting point, but these are the exception. Sodium and potassium have low melting points. Diamond, you know, diamond is very hard substance, so it has generally high melting and boiling point. Actually non-metals has to what? It should be low melting and boiling point, but it is exception. It has a high melting and boiling point. Now you see this density, alkali metals have low density just like non-metal. These are the exceptions only. Alkali metals, that is sodium, potassium, these are low densities just like non-metals. So thank you so much. Study these physical properties of non-metals. Please study the exceptions as well. Exceptions are very important, and if you have any problem, please comment in the comment box. Thank you.